Okay, I'm going to officially get us started doing the introduction. Thank you all for joining us for this discussion on PFAS from a solid waste and wastewater perspective. My name is Susan Schuler, an outreach specialist for Recycling Connections. I'm also the administrative assistant for the Solid Waste Association of North America Badger chapter. Today we're using the Zoom platform for this presentation. If you are new to Zoom, which there's probably not too many new to Zoom anymore, but you all are being put on mute, and we ask that you remain so during the duration of the presentation. For questions and comments that you would like to post, we encourage you to use the chat feature here in Zoom. If you are calling in, please wait until that Q&A section that we open up for asking those questions live. This feature can be accessed by just clicking on the icon at the bottom center of your screen, and it says chat there. So it's a really easy feature to use. Karen Sieg, Executive Director of Recycling Connections, will be monitoring the chat box. She can also help with some technical questions. If you need some assistance there, just in the chat box, you can send a message directly to her. We'll address questions at the end of the presentation. As a reminder, this presentation is being recorded. You can expect a 30 to 40-minute presentation followed by a Q&A for those who would like to stay on for some discussion at the end. Today, let me introduce our speaker, Melissa Johnson. She's the board president of the Associated Recyclers of Wisconsin. She also serves on the board of directors for both the Solid Waste Association of North America Badger chapter and the Wisconsin County Solid Waste Management Association. She works as the director of Marathon County Solid Waste Department. Melissa, thank you so much for joining us today. I'm going to pass this over to you. You can share your screen, and then I'll pass it over to you. Let me know.
Let me host disabled participant screen sharing. So unless you want to put it up and I can tell you when to. You are the host now. Wonderful. There we go. And magic. Let's see. Come on.
Okay.
And there we go. Hopefully this will work. One never knows, right? All right. Thank you very much. Everyone seeing the screen? I guess, Susan, are you seeing the screen?
Yep.
Okay. All right. I am trying to, there we go. All right. As Susan said, I am the director of the Marathon County Solid Waste Department, and I'll share a little bit of information a little later on that's specific to Marathon County. But my role here today is wearing a hat of a statewide leader working on a wide variety of topics. And today specifically, we'll be discussing PFAS. Which has become more and more in the forefront for far too many people, unfortunately. So I'll give you a little bit of background, solid waste and wastewater industry perspective, why we are working together on this. For those of you who are not sort of connected with the solid waste or wastewater industry, we are inextricably tied. Leachate from landfills have to go to a wastewater treatment facility for treatment. Wastewater facilities, whether they're industrial or municipal, produce wastes that have to be managed as a solid waste. And so we're tied. We work together, and on this, we decided we needed to be partners. So the outline for today, just to give you an idea of where we're going to go, again, who we are, our main messages. What are PFAS? And many of you probably already know, but we'll just skim over them and maybe there'll be some new stuff. Why are they PFAS of concern? And again, we use the term PFAS, but it's sort of like a vernacular. It's the common term that we're using, and it captures so many compounds. But for practical purposes, we will continue to use the term PFAS. Where do they come from? Where do they go? Landfills and wastewater treatment facilities, we're at the end of the pipe, We are taking everything that you don't want. Anything you want to flush, everything you throw out. These two industries take care of all of the things that society does not want. And as a result, we end up being receivers of not only PFAS, but many other compounds that have persistent qualities. We'll talk a bit about the financial impact and about some regulatory actions. Again, here are all the partners that have worked on this. We've been working on this just shy of a year. When we realized, DNR about a year ago sent out a letter to 120 wastewater treatment facilities across the state in an attempt to try and gather some information about the existence of PFAS in wastewater. And those facilities were asked to voluntarily collect data, sampling data on PFAS. Well, that really started stimulating a conversation about, what is the intent? What are you going to do with the data collection? What is the purpose? What does this all mean? And solid waste and wastewater folks, we started kind of holding hands and circling the wagons in some respects and said, hey, wait a minute, if we're being looked at as the end of the pipe sort of focus, we really need to start being at the head of the line in the discussion. So the Wisconsin Badger chapter of the Solid Waste Association of North America, the Wisconsin Rural Water Association, the Wisconsin County Solid Waste Management Association, Associated Recyclers of Wisconsin, and the Wisconsin Wastewater Operators Association. All of the boards of all of these organizations have agreed to be a part of representing this webinar. Our main messages, and again, this happened as a result of a very deliberative process and negotiations, discussions, siphoning of information. What is our message? What are we hoping to achieve? And the first one is really this. And all of these three things that you see here, these are things that we, my colleagues and I from both wastewater and solid waste, have mentioned at WISPAC meetings and other DNR meetings. Number one, PFAS are a global issue. We cannot, solid waste folks are systems thinkers. We have to be, right? Because we don't know what you're going to send us. So we have to figure out from a systems perspective, how do we address this? And PFAS are a perfect example of a system that affects us globally that we're looking at sort of very fractured approaches to managing the issue. I want to preface this one thing, and it's not written here, but our industries, the solid waste industry, the wastewater industry, we are in no way trying to minimize the concerns and the fear that some communities are facing because of PFAS. Those fears and concerns are real. We would never try to minimize that. In fact, we're hoping that we can help fix that by coming up with some global solutions. And I know there was a release up in Marinette over the weekend of some possibly contaminated water, PFAS contaminated water. Again, these are real concerns, but we really hope that we can have a global systems-wide discussion. So if we're going to solve this, we have to have that systems approach to managing PFAS. Mitigation is going to be expensive. And any of you on the phone or on the line or online that are policymakers, you know the choices that you have to make when it comes to divvying up how budgets are allocated to address these sort of things. Do we send money to non-point source pollution of phosphorus? Do we send money to, to minimize and mitigate particulate matter? Do we replace lead service lines in communities where it's a threat to public health? There are tons of places to send money. The mitigation, the management of PFAS is going to be expensive, and we need to have a thoughtful planning on our priorities and how best to manage those costs. And finally, and this shouldn't come as a shock to anybody, regulations need to be well-founded in fact and in science. So what are per and polyfluoroalkyl substances, PFAS?
So today we're going to go explore the little marine area. We're anchored out here, but
we get somebody, did you get that? Susan, mute them.
Yes, I'm working on it.
Okay, thanks. So again, you always assume that your audience doesn't fully understand, have the same understanding of the situation, but I saw many of the names on the list, and most are well informed. But we all know these are thousands of compounds used in even more, hundreds of thousands of ways. We love PFAS. As a society, we love PFAS. And a short story for you, I did this presentation similar to this to the Environmental Resources Committee of the Marathon County Board. And there was a reporter there. And as I finished, I stepped out of the room. He came running after me. And he said, you know, Melissa, I was getting ready to really drill you on why you're not doing more at the landfill to manage PFAS. He said, but then you mentioned Gore-Tex. And that PFAS, Gore-Tex have PFAS in them. He said, I love my Gore-Tex jacket. He said, and now I'm not so sure I want to grill you about you at the landfill doing something to manage PFAS. So we as society, we're all responsible. We're all using it. We love our stain-resistant products, especially if we have kids and dogs. They're pretty much everywhere. And they're beneficial. I just bought some new furniture. I'd really like it to last. It does have Scotchgard on it, which will help its longevity. Our outdoor gear, again, that Gore-Tex, we love it to be rain resistant. And another story, I was at an event where they were using paper plates or paper compostable boats for the product the food vendor was selling. And these were just paper. They had no PFAS on them, no wax coating at all. And I sat down and I had, you know, a pair of nice shorts on, a nice outfit. And I put that boat on my lap. And all of a sudden I had this monstrous grease stain on my fairly new shorts. So they have properties that we've become accustomed to in our lives and expect. You know, car seat, if anybody's had a 3-year-old in a car seat with an ice cream cone, you know that you probably appreciate the qualities of PFAS. And again, to the food containers, I've also been adjunct faculty at UWSP, continued to mentor students in the waste management program and work closely with that program. But in my first year of teaching, I had a graduate student who was working on determining the level of fluorine in compost when fast food paper wrappers and containers were composted. And this was in 2012, I believe. So already then we were starting to recognize that while these type of wrappers and food containers have compostable qualities, and some of them may even have recyclable quality, they do contain PFAS, and the residual fluorine persists in whether it's your landfill, compost, or if it's in a bale of mixed paper headed to a paper mill. And interestingly, one of the biggest exposure routes for adults, so it's not being exposed to the chemical, because many of us aren't going to get close enough to firefighting foam, which is one of the bigger sources. But the largest exposure route for adults is in the food we eat, whether that's a French fry or a lovely steak or a salad or a cookie. That is the largest exposure route for adults. The secondary exposure routes for most people, and one of the biggest exposure routes for children, is in the dust in our homes. Now, if you think about the dust in our homes, think about, well, if children ever return to school, of course, that's a completely separate issue, but let's assume we're post-COVID and children return to school. And so many of the schools now, the rooms are carpeted, and of course, that carpeting is PFAS, Scotch guarded in some way or some sort of stain-resistant coating. And I mentioned this at a WISPAC meeting. What we mitigated and abated asbestos throughout the 80s and 90s in all of our schools, and this was a wonderful thing, right? To minimize or eliminate the exposure to a very dangerous compound. What does this look like if we have PFAS dust from building products, primarily furniture and carpet in our schools, and that becomes an exposure route, a significant exposure route for children? What does that mean? I don't have the answer. That's a rhetorical question, but it's something we do need to consider. Again, why are we concerned? These compounds, they're chemical bonds, these carbon bonds, carbon fluorine bonds, just don't break down. They love each other. And even in high temperatures, it takes incredibly high temperatures to break these down. And interestingly, what we're finding at some incinerators taking in some of the PFAS is they're starting to see soil contamination in and around, in proximity of those incinerators, seeing fluorine and PFAS concentrations in the soils. They just are incredibly persistent. And interestingly, they are one of 12 of the persistent organic compounds, or pollutants, that were identified by the United Nations Stockholm Convention on Persistent Organic Pollutants. So PFAS, or the category of PFAS, are only one of 12 persistent organic pollutants that we have to deal with on a worldwide basis. But we already have some understanding that they do have health concerns, including possibly causing cancer, causing some thyroid issues. So again, nothing to be taken lightly, and we are not trying to minimize that concern at all. In fact, we're hoping we can help build a solution to minimize that concern, that issue. Of note, you should know, and this is, there's another slide coming up, but in the early 2000s, the PFOAs were actually discontinued in use or production in the United States. And since then, we've seen a constant decline of these compounds in the blood serum of people in the United States. So eliminating their production is we know that that will be the way that we can fully eliminate the human health threat and the environmental threat. Again, we've talked about this a little bit. Low infant birth weight, of course, this does apparently have a mother to infant in utero connection. That is of serious concern. Of course, we want to make sure our children are born healthy and whole and have every possible happy, healthy experience. Increase in cholesterol. We already know that this is a significant issue and a significant cause, increased cholesterol, that is, of both stroke and heart disease. So anything that would increase that would certainly increase the potential for increased heart disease. Weakened immune system. These days, what we're hearing? People at risk from COVID are those with weakened immune systems. So if we have something in the environment that's weakening our immune system, we certainly want to try and eliminate it from the environment. Unfortunately, there is a cancer risk and, of course, thyroid hormone disruption. And again, I talked about those sources of household dust in our diet. Indoor air, that's where we're going to find this. This gets a little complicated, but it helps to illustrate the complication of this compound and how it just circles in the environment. It's in our, we go to the grocery store, we go to the retail store, and we buy products that are filled with these things. We dispose of them. We expose ourselves in our homes through the dust, the food we eat. We then toss out the products that we don't want. We flush our toilets, things go down the drain. They end up within the waste infrastructure. And within the waste infrastructure, then we have another pathway for getting it out into the environment. We receive it, whether we're a wastewater treatment facility, a solid waste facility, and that can be a compost facility, it can be a recycling facility, or it could even be a post-consumer paper mill taking in post-consumer papers that have PFAS on them. And then of course, in the production of, or the management of all of that, whether it's management of leachate, the management of sludge, that cycle continues. It just continues over and over and over. Go back to this and just, there is some evidence and that it does bioaccumulate in the food chain. There was a story, I believe it was either out of New Hampshire or Vermont, of a farmer whose crops had cropland that had been exposed to PFAS through sludge application, and he was having a bioaccumulation of PFAS into the food that was being fed to his cattle, and unfortunately that cycle was working its way through the cattle. So it does bioaccumulate in the food chain. It does bioaccumulate in our bodies. I believe it attaches to the protein. I am not an immunologist, nor am I a physician, and I don't know exactly that pathway, but it does stay in our bodies. And again, I mentioned previously that the limiting of PFAS in the manufacturing has caused a decrease in the amount of PFOS in the blood serum in humans in the United States. And you can see that illustration of how that has declined. So clearly that seems to be key. That seems to be key in hopefully helping people who are concerned about this bioaccumulation in their bodies and in our environment. And again, just another illustration of landfills, and I would say landfills, compost facilities, because some large compost facilities do have to manage leachate, to wastewater treatment plants. We are not sources of PFAS. We receive it. We receive it from you. We receive it from our industrial customers. We receive it from everybody who wants to get rid of the stuff they no longer want. And again, at the very bottom, you see farms listed there as receivers. Farms are receiving it because they are receiving biosolids as a soil nutrient and soil amendment, which has been pretty successful in diverting hundreds of thousands of tons of sludge from landfill disposal into beneficial use as biosolids. I had some students working on that project this year on estimating the amount of sludge that would have to be landfilled if biosolids were banned from land application. We would need an additional 500,000 cubic yards of landfill airspace every year to manage sludge that now would not be able to be beneficially reused. Of course, with that comes the additional cost of managing that for the municipalities and for our industries. Again, we are not the sources, but we are the receivers. Again, another illustration of that back and forth relationship. Quick story. So last year when that letter went out from the DNR to a variety of wastewater treatment facilities, one of those facilities was the location where Marathon County took all of our leachate for treatment before being discharged into Wisconsin River. We had had a relationship with this location, which is a paper mill, since 1980. They treated our leachate. We in turn provided them landfill disposal, and it was a win-win relationship. After they got the letter from the DNR, they pretty much said, "Hi, Melissa, we'd like a divorce. We no longer want to have the long-term relationship that we had." Because part of the concern was there were words that were being used like responsible parties. And this particular landfill became concerned because they do not use PFAS in their production. Now, because they were receiving leachate not only from Marathon County, but from a couple of other sources, they would be considered a responsible party in Wisconsin River cleanup for PFAS. And they wanted to eliminate any possible liability. They wanted to get rid of it. So now We manage 17 million gallons of leachate a year. I have to find a home for that, 6,600 gallons at a time. That's how much fits a tanker. So what happened was we did find a location. We found 3 locations. However, they're all farther to drive and the leachate treatment costs are more. In fact, because of that concern, not so much that our leachate was bad, not so much that we didn't have a good working relationship, not so much that they couldn't treat the leachate for the normal sort of things one would do that for, but because of hyper concern about liability related to PFAS. The result is it will triple my costs for managing leachate. Now, my department doesn't use tax dollars, but the biggest users of my facility are municipalities in central and north central Wisconsin. We work very hard to keep our costs affordable for our municipal customers because we are very mindful of levy limits. We also support a wide variety of community programs from medication drop boxes to help household hazardous waste to recycling education. We will probably have to pare back our support because of increased costs for leachate. And again, if we were to truly treat for leachate, or treat for PFAS, remove those PFAS, it'd be very, very expensive. Whether we sequester it, so put it into a filter or somehow lock it into concrete, we haven't removed PFAS, we've just stuck it somewhere. That is very expensive. Destruction, we're not sure how to do that yet. So as we move forward, are we going to be putting good money after bad with an uncertainty of how best to either sequester or destroy and still not really solve the problem? Whether it's granulated activated carbon, which is a filter that could grab some of those PFAS, that filter then has to be managed as either a solid waste or a hazardous waste. Whether it's reverse osmosis, all of these things do not change the fact that the PFAS are still there. And we really need more research, and that takes money. We have to, if we're going to look at a technology to remove these at the end of the pipe, we have to make sure that we're doing the right thing and not just investing a lot of money and finding out that it's not working, or that we've just moved the problem from one place to the next. And I saw one article where someone in a community had said, oh, we got rid of our PFAS problem. We sent all of that PFAS, I think it was soils, to somewhere else. Well, you know, boy howdy, good for you, but somewhere else now has a PFAS problem because they have to figure out how to deal with it. So we need more research on the best mitigation approach. And this just illustrates that there really is no standard at the moment. We are all over the place. You can see US EPA is looking at 70 parts per trillion, New Jersey at 14, Wisconsin's looking at somewhere in the 2 to 20 range. We're all over the place. And part of it is because we haven't had any national leadership on this. So the states, of course, are doing their job because the state's job is to protect the interest and the health of the people who live in its state. So given this wide range, it makes it very hard to say, yep, here's the number, this is where we've got to be. There's still a lot of uncertainty. And again, many of you know this already, especially our friends from DNR on the call right now. This is the timeline for the PFAS limits. We're a little concerned in our industry, both solid waste and wastewater, that we're going to set limits that are going to be impossible to meet. And I'll give you another illustration. There's an article recently that I read. There's a researcher out of UW-Madison, and he has measured PFAS in rainwater in the United States, so capturing fresh rainwater. And some of the lowest concentrations were 0, but generally there were PFAS and PFOs being detected in rainwater falling from the sky. So we do have concerns that we're going to have limits that we're not going to be able to meet. Again, to fix this, we have to look at the entire system from source to sink. We need a holistic, systematic approach. We need regulatory action. We need funding for assessments and treatment, mitigation, remediation. All of our communities, I mean, we'd all heard the governor saying that all agencies need to cut their budgets. Every municipal budget is doing the same thing. How do we fund this? Who funds this? How do we find out the answers? There needs to be money put into this. This is a serious issue. We need to look at phasing out the use of PFAS by manufacturers. In the Scandinavian countries, what they're doing is they're using a methodology called the essentialness or necessity of the PFAS. Is there some other compound that is less toxic, less problematic, less bioaccumulative than PFAS that can be used to coat our pans, to prevent stains on our carpet, to put out fires? So I think we should be looking at that essentialness approach. Do we really need it in our cosmetics? Do we really need it in our wrappers for our French fries? And you know, we need to look at the successful and cost-effective treatment and removal technologies. So not only saying, here's a technology, we're going to do this, try to get to that limit. Is it successful? Is it sustainable? Is it cost-effective? Is it achieving our goal? And we really do, the legislators that have been working on this, we're heartened by the fact that so many of them are doing such good due diligence in really looking at this from an objective, science-based approach. To me, there's no other way. I'm a policymaker here in central Wisconsin. In my private life, I do the research. I see you know, a state legislator doing the research on policies. We need to recognize that from production to consumption, we need everybody in this. We cannot be at the end of the pipe somehow solving the problems of society. We need sound science, and we need to have the financial support if we are going to solve this problem to help the receivers. Wisconsin landfills, compost facilities, wastewater treatment plants. We can't do this alone, and we cannot be a target. And it's all too easy to point a finger, and this is what I've found. When we point a finger, that's when we eliminate and walk away from our own responsibilities. We are all in this together. And we've heard this about COVID. We are all in this together because we're all bound by a common theme of working to protect human health and the environment. And again, thank you so much for listening. I think I just about made my time limit, and anybody who knows me knows that I always run over. I love to tell stories and talk, and my dog's barking. Sorry about that. Here's information on the organizations where you can find out more information about us and where you can actually contact us as well. And again, thank you so much for taking the time. I hope this opens up opportunities for robust discussions on a holistic approach to solving a really, really complex issue. So thank you very much.